Hello everyone, welcome back to my channel. Today we will be solving odd even linked list from LeetCode. As you can see, the difficulty level of this problem is medium and you can see the number of likes for this problem. So by that you can imagine that how good or bad this problem would be. I'll start with the problem description and we'll try to understand the given problem, and then we'll try to come up with a brute force approach solution to this problem, and then we'll see if we can optimize this in a better way. And at the end we will also see the coding solution for this given problem. And also, if you're new to this channel and you are interested in competitive programming or any other tech related stuff, you can check out the content on our channel, and if you like the content, please don't forget to hit the subscribe button. So let's start with this video. So I'll go through the problem description. Given a singly linked list, group all odd nodes together followed by the even nodes. Please note here we are talking about the node number and not the values in the node. Okay, and you should try to do it in place. The problem should run in order of one space complexity and order of nodes time complexity. That means your solution shouldn't be using any extra space, and the time complexity should be order of nodes. That means order of n, because n is going to be your number of nodes present in the given link. So let's go through this example one. So here we are given this linked list 1, 2, 3, 4, 5 null, and the output should return me 1, 3, 5 and 2, 4. So as this problem says, we need to group all the odd nodes, and by odd nodes they mean the nodes which are present at the odd position. So for this example, 1, 3, 5 are at the odd position and 2 and 4 are at the even position. So we should be grouping all the odd nodes. So for example, 1, 3, 5 are the odd nodes, so it should come in the beginning, and then we should be appending the even nodes, which are 2 and 4 in this case. Similarly, if you see the second example, we are given this linked list 2, 1, 3, 5, 6, 4, 7. So for this one, 2, 3, 6 and 7 are the odd ones. So you see 2, 3, 6, 7 are at the beginning, and 1, 5, 4 are the even nodes which are at the end. So here we need to group all odd and even nodes. So I hope the problem is clear to you. Next, I'll go through the constraints. The relative order inside both even and odd groups should remain as it was in the input. So for example, let's say in example 1, 1, 3, 5 are the odd nodes. So in that case, the sequence should be 1, 3, 5. Though all the nodes are odd, but still we need to maintain the order. So let's say you cannot return sequence 5, 1, 3 or 1, 5, 3 or 3, 1, 5. You have to follow the order as in the given input. So I hope the first constraint is clear. Next is the first node is considered odd and the second node even, and so on. So here the first node is odd, second is even, third is odd, fourth is even, and so on. Okay, and the last one is the length of the linked list is between 0 to 10 to the power 4. That means the number of nodes you can have maximum in your linked list is 10 to the power 4. So I hope the question is clear. I'll try to explain the problem objective once more through the presentation. So let's say if you are given this linked list and you know that we are considering the first node as a odd one and the second node as a even, then third as odd, then fourth as even, and so on. So if this is the case, then the expected output would be something like this. You need to group all the odd nodes. Okay, in this case 2, 3, 6, 7 are the odd nodes. As you can see in the previous slide, 2, 3, 6, 7 are the odd nodes. So we are grouping it at one end and then we are grouping the other end with the even nodes. So at the end you should be returning the linked list in this form. So yeah, that's about the problem description. Now we'll see how we can solve this problem. So the idea here is that now we'll try to think of a solution. So as they have already mentioned in the problem that we shouldn't be using any extra space, and also we need to maintain the time complexity of order of n. So before going to that optimal solution, first I'll discuss the brute force approach. So what could be the brute force approach for this given problem? So in the brute force, what we can do is we can simply iterate over this linked list in a manner where we can group the odd and even nodes. So for that, what we can do, we can simply iterate over the alternate node. So for example, if we start with the first node, from here instead of going to the immediate next node, what we should be doing, we should be going to the next to next node. So for example, let's say if you have the reference of this node in some variable temp, then instead of doing temp.next, we should be doing temp next.next by simply checking if there is any existing node. And in the similar way, we should be going to the other alternative node. And in this way, we should be iterating until we reach to the end of the list, right? So in this case, what you will get, you will simply get all the odd nodes because you are skipping the in-between nodes, right? So while iterating over these nodes, what we can do, we can simply copy these nodes to create one another linked list, right? So that you can have a linked list with all the odd nodes. And then after completing the visit of all the odd nodes, what you can do, you can simply start iterating in the same manner for the even nodes, right? So here, instead of starting with the first node, you will be starting with the second node where you will start with head.next, and then you will iterate in the same manner where you will be skipping the middle node and then you will be jumping to the next node, right? And from here again, you will be jumping to the next to next node. So in this way, you will also complete the even nodes, and in the similar way you will keep appending these nodes to the newly created list, right? So in this case, at the end you will get a linked list where you will have all the grouped odd nodes and all the grouped even nodes. Here the complexity is that you are traversing this linked list twice, one for the odd nodes and another for the even nodes, and also you are creating a new linked list. That means you are using some extra space, which is one of the constraints for this given problem. So yeah, that brute force solution is good enough for a small linked list, but in this case, if you get something which is having 10 to the power 4 number of nodes, then obviously you will get a time limit exceeded error, right? So in that case, we'll try to optimize this solution. Okay, so to solve this problem optimally, the idea here is that if we can rearrange these pointers in such a way so that we can split this particular linked list in two different linked lists. One would be with all the odd nodes and other would be with all the even nodes. So for that, the intuition is something like this, where you split the given linked list in two linked lists, one with the odd nodes and other with the even nodes. So next we'll see how we can achieve this. So for that, let's say we are given this linked list and here is the head pointer which is pointing to the first node, with which we can simply access this particular linked list. So initially we will require few pointers or references before iterating over this linked list. So it will be something like this, where we will be having 3 more extra pointers. So the first one would be the odd pointer, which will be pointing to the first node, and even pointer, which will be pointing to the second node. As we know that the first node is always the odd node and the second node is always the even node, and so on, right? And we will also require an even head pointer which will be pointing to the second node. The idea here is that by using these pointers, we will be able to rearrange these pointers in such a way that we can group all the odd nodes and all the even nodes. So now we will start with the iteration, and this iteration will run until this even pointer reaches the end of the linked list. So let's start iterating over this linked list. So the very first thing we need to do is we should be changing this pointer to point to the third node instead of the second node. So ideally a odd node should be pointing to another odd node, right? So after the first node, the next odd node is the node with the value 3. So we need to change this pointer to point to this node, right? So here we need to change this particular pointer to point to the node with the value 3. Okay, and for that we have to do odd.next equal to even.next. That means this pointer will start pointing to the node which is being pointed by the even node. Here the even node is pointing to the third node, right? So as soon as you put the even.next in odd.next, your pointer will look something like this. Now 2 is pointing to 3. So after changing this pointer, we simply need to move this pointer here, right? So for that we simply need to do odd equal to odd.next. So now the odd is pointing to the node with value 3. Now we need to do the similar thing for even node. So here in the even node, we simply need to change this pointer to point to the node with the value 5, right? For that we simply do even.next equal to odd.next, right? So after this, the node with value 1 will start pointing to the node with value 5. And in the similar way, we need to move this even pointer to the node with value 5. Okay, so now it looks something like this. So after first iteration, you can see that the first odd node is pointing to the second odd node and the first even node is pointing to the second even node. So from here, we should be iterating this process until even pointer reaches to the end of the linked list. So similarly, next what we need to do, we simply need to change this pointer to point to the node with value 6, and we need to move this odd pointer to the node with value 6, right? So after executing these two lines, you will get something like this, where your odd node with value 3 will start pointing to another odd node with value 6, and your odd pointer is also pointing to the node at value 6, right? So here we'll do the similar thing for the even nodes. So now this 5 will start pointing to the node with value 4, and this even pointer will start pointing to the node with value 4, right? So after executing these two lines, you will see something like this, where 5 will start pointing to 4 and even pointer will start pointing to 4. Now we'll again repeat the same thing, where 6 will start pointing to the node with value 7 and will move the odd pointer to 7, right? That means you are executing these two lines. So after that, you will have something like this, and then we'll do the similar thing for the even node. Now this pointer will start pointing to null, and also this even pointer will start pointing to null. So after executing these two lines, you will have something like this. Now as this even pointer reaches to the end of this linked list, that means the iteration is over. Now if you see this linked list structure carefully, you will see two different linked lists you have right now. So one which is being pointed by the head, and from here if you see, we have 2, and from here 2 to 3, 3 to 6, 6 to 7, and then it points to null. And the other one is with the even head. Here if you see, this is pointing to the node with value 1, then it is pointing to the node with value 5, then it is pointing to 4, and then null. So in a nutshell, you have these two different types of linked list, right? So if you compare, you have one with the head node, one with the even head node. And for the head one, you have this odd pointer at the last node. So in the similar way, if you see, the one which starts with head is something like this, and the one which starts with even head is something like this. Now all we need to do is we need to append this first node at the end of this node, right? And that's what we want to achieve. So for that, all we need to do is odd.next should start pointing to even head, which means the node with value 7 will start pointing to the node with value 1. Right? So after this, you will get something like this. Now if you see, you have all the odd nodes grouped at one end and all the even nodes grouped at another end. And from here, what you can do, you can simply return the head, right? So if you return head, you are returning your expected linked list, right? So I hope the explanation is clear to you, and also if you notice we haven't used any extra space, that means the space complexity should be order of 1, and also we complete this entire process only in one iteration. That means the time complexity is order of n. So now it's time to see some code. So for that I'll simply go to the LeetCode website. So here I have already written this method. So I'll just go through it. I'll explain. This is similar to what I have shown in the presentation. So here in this method, they wanted to add me this logic where I'll simply get the access to the head node. Okay. So the very first thing I'm doing here is I'm simply checking if the head is null or if the head.next is null. That means if you get an empty linked list or a linked list with only one node, I'll simply return the head. Otherwise, I'll simply initialize these 3 pointers which I have shown in the presentation, and then I'll simply start iterating over this linked list until this pointer even and event.next is not equal to null. And in that case, what I'll be doing, I'll be simply changing the pointers of the odd node to point to the next odd node, and I'll keep on moving the odd pointer, right? And similarly, I'll be simply changing the pointers for all the even node to point to the next even node, and then I'll also keep moving the even node, which I've shown in the presentation, right? And at the end, what we need to do, once we complete this iteration, we simply need to merge the odd list with the even list, right? And then we are returning the head node. So I hope this solution is clear to you, because this is very straightforward and simple. The only tricky part here is to come with this intuition, right? So I'll simply run this code first. So here it got accepted for this input. Now I'll submit this code so that it can run this particular solution in different test cases. So here if you see, this solution got accepted, and if you see, this took only 0 millisecond and this much memory. So I hope this video is helpful to you. I would highly recommend you to keep practicing and solve more and more problems, and this will definitely help you to crack any coding interviews. And also, if you're new to this channel and interested in competitive programming, don't forget to hit the subscribe button, because I'm going to upload more such videos which will help you to crack your coding interviews. Thank you for watching.